All right, welcome to lesson 4 of engineering problem solving with computers. This week we're going to use Matlab. It's a new tool for us, but it's a very powerful tool for doing numerical methods of all kinds, and so I think it's valuable for us to take advantage of its capabilities. Matlab began as a tool for doing linear algebra, and originally that was pretty much all it did. But it's since added quite a lot of functionality, and so even though it still has a kind of a linear algebra feel to it, it can do just about any problem you need to address. It runs on all platforms, which is nice, and if you get into it and want to add more functionality, there's toolboxes available that you can purchase and add into your Matlab installation that add quite a lot of functionality. So there's toolboxes for optimization, control theory, control methods, image processing, all kinds of stuff like that. And so I encourage you to take a look at the MathWorks website and see what's available. The user interface is not as GUI oriented as you might be accustomed to. If you're used to doing your problem solving in, say, MathCAD or Excel or even Mathematic or Maple, you'll find this to be more command line driven than those, and therefore it'll seem a little low tech, but I think it's quite powerful, and so I encourage you to stick with it for a while, and you'll get used to the command line orientation. You can just sit at the command window, open up Matlab and start typing commands, and you'll see the output right away. In that sense, it's quite interactive. The problem is if you work that way, it's difficult to save results. If you do file save, you'll save the answers to everything you did, but not the inputs, and so you can't really make edits. The way you'll want to interact with Matlab is through M files. These are just script files, and they're called M files because they have a .m file extension. And they're just a list of Matlab commands, and you save these in this text file. Then you tell Matlab to run that script, and it'll run through the script and execute all the commands one by one, and you'll see the output. And there's a built-in editor just for editing those scripts, and we'll spend a lot of time in that. So the way I do problem solving in Matlab is I put these commands into an M file, I run them from the main Matlab window. If there's an issue with them, I'll go back to the editor, edit the M file, and rerun, and I'll continue that process until I get everything the way I want it. Then you just save this very small text file, and that's how you preserve your work. Or if, for example, in this class, when you turn in homework solutions to me, you'll just send me an M file, and I'll run it through Matlab and see the results. Okay. So let's just see some of the basic commands in Matlab. Assigning values to a variable is quite simple. You just say a equals 5, for example, and that'll set that a to be 5, b equals 3, c is a plus b. You know, all this works exactly like you'd expect it to. But as I said, there's a linear algebra orientation to Matlab, and so we need to be able to create vectors and matrices. Okay, so to create a vector, you just put the elements of the vector in square brackets, and you separate them by a space. So for example, this v1 is 0, 1, 2, 3, 4 in square brackets, makes a vector, which is the list of integers from 0 to 4. There's also a repeat or repetition operator, a colon. So if I say v2 is 0 colon 4, it gives me exactly the same result. It gives me the integers from 0 to 4 in a vector. Matrices are similar. We still use square brackets, but you separate rows by semicolons. So I say 1, 0, 1, separated by spaces. That gives me row 1 with 3 elements, 1, 0, 1. Then I go put a semicolon, go to row 2, I get 0, 1, 0. And then I go to row 3, get 0, 0, 1. So this would be a 3 by 3 matrix. 1, 0, 1 is the top row, 0, 1, 0 is the middle row, 0, 0, 1 is the bottom row. There's also some commands for creating specialized matrices. For example, 1s of 3 gives me a 3 by 3 matrix filled with 1s. There's a similar thing for zeros, and there's many other commands for creating specialized matrices. Now sometimes you want to get at a certain element in a vector or a matrix, and you just use parentheses now. So v1 of 3 in parentheses gives me the third element of the vector v1. m1 of 2 comma 3 gives me the element, it's in row 2 column 3. I can use this repetition operator again. So m1 of colon comma 2 says give me all the rows in column 2, which basically returns column 2. And m1 of 1 comma colon says give me all the columns in row 1, which essentially returns row 1. So I can pick out a row or a column or a single element quite easily. Now, one thing that'll be a little strange for some of you, especially early on, is vector math. So by default, MATLAB wants to use vector math on anytime we do an operation on a vector. So for example, if I define a vector v to be the integers from 0 to 5, and then I say z equals v times v, it doesn't square each element in v and return it as z. It tries to multiply the vector v times itself, and that's actually not allowed. I could do the transpose of v times v, and then I would get a vector math result out of that, and that would work, but that would just be a scalar. If I want to square each element in v and return it as a new vector z, I use a dot before the operator. So v dot times v will take each element in v and multiply it by itself. So z becomes the squares of the integers from 0 to 5. There's a similar operator dot slash or dot caret. So another way to square each element in v is to go v dot caret 2, which will raise each element in v to the second power. Okay. In this class, we will basically never need vector math. So if you're at all unsure about whether to use a dot operator or not, just put it in and it's not going to hurt you. As you get a little more sophisticated with MATLAB, you can write some very efficient scripts by taking advantage of the vector math. But at the level we're going to deal with MATLAB in this class, you won't need it. Okay, so when in doubt, put in the dot with the operator.